test whether you can speak out or no, whether you can unmute your mask, unmute your mic, and then whether you can communicate or not. Please check that, because without communication, one-way talk doesn't look okay. Please check whether you can speak or not. All right, in the chat box, whether it is possible for you to unmute and ask the question.
Yes, sir. I think it is possible.
Yes, okay, good. So that you can interrupt me anytime. That will be better rather than passive listening. So, uh, my idea for today's session is totally three things. One is the non-parametric test, which is very easy, but then because of the word non-parametric, people afraid. Basically, for the clinician and even on the community medicine people, when a sample size is smaller, at that time it is useful. Second thing is we need all of you are required to prepare one project proposal, send it for the purpose of the funding purpose, and then get the funds if possible. And third thing is, in nowadays there are lots of tests are increasing. The medicines, invention for medicines, right, and invention of lab tests are in a race. But which test is to be used when and why laboratory test is required and why not? So, if let's say there are around 300 chemicals or molecules in the body, and you find all these 300 chemical at a given point of time, there can be ups and downs. If you take a video, that's okay. But if you take only one picture, that may be the sufficient, may not be sufficient, and you can't give a lot of pricks to the body to find out the videos. And that's why non-invasive tests are required, which can give you the picture like a video rather than only the photo. So, and that's why how to use the screening test. These three things I want to take. In previous session, I could not complete the non-parametric test just because of some internet connection problem. I hope today you are able to listen me properly. Now, this folder will be going for non-parametric test. And there is a good question to all of you that if you have not completed that online test, the biomedical, the basic knowledge in the biomedical test, that exam, if you have not given, you should complete the things and take the appointment for exam. Usually, it will be somewhere in the December or so. So go to the Swayam website. I have already given the link and try to finish that. Now we first go with the main written test. Spelling and etc. will be difficult, but the actual test is not that difficult. It's very easy. Just have a few minutes for to me. If it is even repetition, that will be useful. Now, this Divakar Sharma is a professor, and probably now is a professor. He has taught me this test, and I like it very much. And the Wilcoxon sign rank test is still better because sometimes there'll be improvement, sometimes it may be worsen. And most of the time, you see the people say that my all the patients are correct. 100% I get a result. The moment a person talks about 100%, you should believe that he might have treated only 3 4 cases and got a 100% result, or he is 100% liar. If he has treated less than 1,000 cases, there has to be bound to be a failure. And when a person says, I have no failure, that means don't discuss much with that person. And that's why in this time the interest is very interesting. It considers both minus and plus. Now, when we first go with the man with interest, also known as Wilcoxon rank sum test, because there is some ranking, rank sum test. It is used to comparing two groups by ranks. And it is a non-parent test used to determine whether two samples of ordinal rank data differs or not. If, say, for example, there are marks, right, 100 marks, 30 marks, 40 marks, that's a different thing. But when it is a rank is given, first rank, fifth rank, seventh, sixth rank, like that, at that time, ordinal data, how do you do the analysis? And is equivalent to independent t-test. This t-test basically we are using to compare two groups when the data is can be when you can find the mean, etc. Continuous data is available to set of data, and you can use t-test, paired or unpaired t-test. Now, in the procedure is uh, the sample is selected from two independent population and representative of the population. You are basically compared to sample. Essentially, you are comparing two population from which it is drawn. When the word is sample is used, suppose I have a population of 10,000 population, and if I consider all the 10,000 population, can I talk that I have done a sample? Yes or no? If a 10,000 population, I measure all the 10,000 population. Can I say that I had taken a sample? Yes or no? Very small question, but very interesting. Or you can give me answer in chat. My question is, I have 10,000 population. I have taken sample size of 10,000. Can I say I have taken a sample? Yes or no? Either write in chat or give answer. So it is very important to have a definition of sample is any subset of the population. So even you say take a full sample population, you can still theoretically call it as a sample. Out of 10,000, if you take 9,000, that is also sample. 100 is also sample. But sample can be of two types, a representative or not representative. And if you want to find out that whether sample is representative or not, and suppose you have taken a height and you find out two groups, whether this and let's say each group is containing around 400 people. And if you compare height of 400 people, you want to find out whether the difference between two populations is significant or not. This population A and population B from both 400 were taken. Now, which statistical test you are going to use it? Can you tell me that? You should be active. At least you should write, no, I will not be able to tell. If you are not active on the chat board, that means you are not attending. You're doing something else. Because you are comparing, going to compare two means, you are going to find out standard error of difference between two mean that you are going to use. But if a sample size is, let's say, in one group is 25, other group is, let's say, 28, and the same height you are going to compare, then you are going to use unpaired details because sample size is small. If a large sample size, you can go for Z test. But in this case, it requires two set of data. This need not be paired, nor need they be normally distributed, nor need there be equal numbers in each set. Different things are there. Now let's see actual the example. There are two sets, one set of data, second set of data, and we want to compare. Now here we say that it is not the actual number; it's the classification. Category one, cat two, cat three, cat four, cat five. And now we want to compare the things. Category may be based on hemoglobin, based on the height, based on the weight. It can be based on the RBC size. So many things can be there, and that the measurement data is converted into the rank, right? And it has a meaning. Rank all data into ascending order and then recode the data set, replacing raw data with ranks. Now, this sentence you will not understand unless you go further. This is very clear now. Just spend 1 minute over here. Total number are 13. Total number is 13. Making both the set together is 13. Series A and series B. Now, think that all these are from a single set and then give us them number. One is naturally number one, but another one is not number one. It is give it to two. Then number two is three. Another number two is four. Is like this. You can see that one, two, three, four, like this. Right? Is it clear? Now, the next thing is harmonized rank where the same value occurs more than once. Because one, you have said one, another one you rank as two. But now, if you want to harmonize, you need to take average of these two. Look at over here. One in this case was having one, here two. So one and one. So one plus two is three. Three divided by two is 1.5. So we are keeping 1.5, 1.5 over here. Similarly, for 4, if you say this is 7, this is 10, 9, 8. So 4 are repeating 4 times and rank like 7, 8, 9, 10. And you take an average of that, it is 8.5. So all the 4 are written as 8.5. Once you say you are clear, then we'll be moving further. So I presume that you have understood this much. Now, it will take some time to understand. Add up ranks for each column, call this Rx and Ry. This column or this and this, right? That is the Rx and Ry. Optional but a good check. Rx plus Ry is equal to n plus 1 divided by n is a total number, right? N is a total number. Nx and Ny means first category number of observation, second category is Ny observation. Now this much is easy, Rx and Ry, right? But then this Ux and Uy, just when we will calculate, you'll understand more easily. But this is the total of number in X, number in Y, plus number in X, number X plus 1 divided by 2 minus Rx. That means the total of rank. Now, why do we take this? Because out of these two ux and uy, we are going to select a smaller value, and that we are going to find out to convert into a z score. If you have any question, you can ask now or later also. Now, let's go for actual calculation. This is for converting U into a Z. This formula looking very difficult, but is very simple. N1 is, let's say, 7, N2 is, let's say, uh, 6, and you need to multiply. This is as simple as that. So once you get a U value, you can get a Z value. And which you are going to take out of UX and UI, smaller you are going to take. Now, let us see how they are calculated. RX 67, that means total of this, right? This is RX. RY is total of this, is a 24. And for the purpose of checking, it is uh, consider over here uh, 24, then check 91, like that. Yeah, that is not necessary, but just for the sake of. Now, important is UX and UI. This value UX is 3 and UI is 39. So here you are going to select 3 as a UX. And from that 3, you convert into Z. Remember where we were? Originally, you were given two data set, right? Now, if it is given to you and asked that whether there is a significant difference between these two or not, then you may think which test should I use it? There's some kind of ordinal data, and then you need to find out significance between these two populations. And you can say that this is a score which says that is the outcome of some treatment. Is a wonderful treatment, you say 5. Less treatment, 4. Like if not improve much, you can say 1, something like that. So the ordinal data is with you. You want to comment on this. So this was converted into rank. Rank was harmonized by taking an average. Based on that, U was found out, and UX and UI, whichever is smaller, that was U. And now let's see further. U is converted into Z. And here the Z score was 2.57. Now, can you tell me if Z is more than 2, probability is more than 0.05 or less than 0.05? At least write in the chat. If Z is a relative debit, which is more than 2, for example, then probability, P is the probability of event occurring by chance. P is less than 0.05, that is a 5%, into bracket, you can say 5% chance that your theory is right. Or P is more than 0.05. Give me the answer. In this case, Z is more than 2. So what do you think? P is less than 0.05 or more than 0.05? That is one person who should write. Okay. I don't think that you are not allowed to write. If you're not allowed to write, you can speak out or unmute your mic. Then there's no point in learning ahead if you can't answer it or if you don't want to answer it. I will be just looking at you. No response? Yes. So less than 0.0. So in this case, it shows that the difference, there is a significant difference between these two sets. Even it was very small data, we could find out that, right? Now the next thing would be, now we go for the another test, Wilkinson Sandring test. You are free to stop me anytime in between if it is not clear. And you can also write in the group. Now, Wilkinson sign rank test is the non-parameter test equivalent to dependency test. In this case, what happens actually the pre and post, initially what was the situation, what was the situation later on, And what is the difference between two observations that we are going to compare? It is used when we wish to compare two sets of scores that come from the same participant. Samples are randomly selected and representative of the population. There are, let's say, 1,000 patients. We want to take a sample of 10, and then we can compare this. Okay, once more on the man witness test that we can repeat, no problem. Before we go to this, taking a few more minutes on man witness test. First, you understand. Now, if you say again, I ready, but you should be able to write in the chat. This is the first thing that two data set are there. In this case, 1, 2, 3, 4, 1, 2, 3, but sometimes it could be something like 7, 9, 11, 12 ordinal data. It gives some order based on some kind of measurements, right? And can it be ABCD? Yes, it can be ABCD, provided ABCD, according to the serial number of ABCD, is representing some measurements. It is quantifiable in that order. The scale may not be the same. 5, 4, 3 may not be exactly the same. Each interval is the same. It denotes some kind of ordinal data, right? In order. There's two data sets. Here you're going to use man witness test. So first step was you probably have understood 1, 2, 3, 4. One is one, again one, it is two. If it is again one, it is three. That you are going to give ring from 1 to 13. But now this one is one, this one is two, so it is not, it's injustice. So you harmonize and keep both as 1.5, 1.5. This is what we have done so far. And then what we are doing, that we are making a total of this. This is harmonized data, and we make a total of harmonized. And here also. This is Ry and this is Rx. This is 67 and this is 24. And once we have that data, we are finding out UX 6 into 7 because if you want to understand this, let's go back to that formula. This is nx into ny. Both are same. That is 7 into 6, right? And this is 7 plus 7 into 1 is 7 into 8 divided by 2. And this is a total of Rx. It's very simple. So if you compare this, you will get this result 3 and 39. And this 3 we are using to convert into a Z. And that Z is converted over here. And you can see that that is 2.57. Right? So, and because there is more than 2.5, more than 2, probability the difference between those two data set, two samples is by chance is much less. So we say that this difference is significant. If it's okay, then we'll move further for Wilkinson's hand rank test. And this is just like the dependent t-test. The same participant before and after are going to be compared. Two groups should be matched, and the data is the ordinal in this case. Now, there are some of the ranks for positive difference, some of the ranks for negative. There will be both kind of thing, result positive or result negative. And here we calculate the W as the smaller of these two ranks. Say the positive and negative smaller one we are going to use. Now, when we go with actual calculation, it will be much easier and it will be you will be able to understand better. I will read the data slowly. Pain researcher is interested in finding methods to reduce lower back pain in individuals without having to use drugs. So let's say acupuncture person is there or acupressure, electropuncture, or maybe a naturopathy or Ayurveda or allopathy. There are lots of pathis are there. The single pathy or double pathy or mixed pathy could be there. But he wants to find out whether my pathy is important in reducing back pain or not. So he is trying to investigate this and he recruits 10 participants for that study. At the beginning of the study, the researcher asked the participant to rate their back pain on a scale of 1 to 10, with a 10 indicating the greatest level of pain. Is less is 1, greatest 10. After 2 weeks, he asked again to indicate their level of back pain on the same scale. He wishes to understand whether the participant pain levels changed after they had undergone the acupuncture. Now, if you are a researcher, would you like to add something more than this in addition to this, the patient perception? Can you do something other than that? Think of. Yes, it could be pulse rate, it could be blood pressure, or it could be the history of other things rather than only back pain, right? His activity, etc., walking. So just to compare, now let's see in this case what is actual data. In this data, don't afraid of this big table. It's a very simple, and you'll be able to understand quickly. Now the first is the 1 to 10, right? And the rating before therapy was 5, and rating after 4 weeks is 2 in first case, second 8 and 4, then 7 and 5 like this. Sometimes 4 is going to be 7 also. That means pain is increasing. Sometimes pain remains the same. So in first case, pain reduced from 5 category to second category. So it is a plus, plus, plus. Then 4 minus 7 is the minus sign. Right? Similarly, this is a plus and minus signs. Now, once the sign is done, you then take the how much is the difference? Plus 3, plus 4, plus 2 like this. Right? And here it was a 0. Now here you take an absolute value. Now this is a very interesting. Here you have signed the thing, but now when you take the absolute value 3, 4, 2, 3 like this, then you rank it. For example, 1 is 1. If there's another one, it would have been 2, but it is not there. So this 2 is 2, but another 2 is 3. If another 2 was there, then it would have been 4. So similarly, you just rank the data to the absolute value. And once you do this or rank it, then what more you are going to do? This harmonizing. Harmonizing, that means 1 is 1, but 2 is 2 and 3. So against 2 you are doing 2.5, and this 2 also 2.5. Similarly, for 3, 4, you take an average, and that average is written over here. Yeah, I take a few seconds if you have not remembered this. You can write in chat if you not remember. This is the rank, and this data is taken up harmonizing the thing, just what we did in Mann-Whitney test. Now, this again, we want to apply this plus sign, minus sign like this over here. And then we make a total of this minus and plus signs. So W plus is 33 and W minus 12. So here, if you just take all the plus sign only, then it's 33. If you take only minus sign, then it's a minus 12. So W plus and W minus. So in this case, we are going to take a minimum. So we are going to take a 12. W is equal to 12. And the critical value will be finding out from the table. And this critical value is 8. And at that, the p value is 0.05. So the test statistic must be less than this to be significant at this level. So in this case, the null hypothesis is not rejected. Now let us see the table, then you will understand much more. Here is the table is given. This is a zero point 0.05. Now look at this. N is 10. The value is 8. And this is a zero point 0.02. Now our data shows 12. So 12 comes on this side. So instead of 12, if you would have got something like 4 or 2 or 3, it would have been this zone. P less than, this is 0.05, 0.02, zero point zero 0.01. Now we have a 12, so 12 will be on this side. If it is 7, it would have been over here. So again, go back over here. W is 12. If this W instead of 12, suppose it would have been the 6, then it will come somewhere over here. So because 12 is more than 8, p value is also more than 0.05, and that's why we will reject the null hypothesis, the accept the null hypothesis. If p value is less than 0.05, we'll reject null hypothesis. But it is more than 0.0. Probability that this difference could be by chance is more than 5%. So we say that the acupressure is not making a significant difference in the low back pain. Even the data was very small, we could analyze this. Now, I will have a pause over here before I move further. Any question? This is another exercise, if someone wants to do that, but I'm not going to do this right now. Right? So if your question will answer that, else we'll be going for another session on PSBH. Any question, Dr. Tukaram or Dr. Danya? Go through this PPT is given to you and try to understand. Now, today you should be able to uh, decide a list of topic, maybe 5, 10, etc. And by next Tuesday, you should be ready with the decision that you would like to decide this topic, and that topic you should be elaborate and to make a full-fledged the thesis, or you can say the project proposal for the submission to funding agency. Now, just taking a few seconds break. For the medical students, this is a very, very important subject, problem solving for better health. Globally, it is being used, and I learned from the late Dr. C.R. Somin. He taught us this PSBH at NHL Medical College Ahmedabad. And the important point is each one can make a difference. Whether it is Dr. Tukaram or Dr. Danya or anyone, we can make a difference. And each medical student can make a difference. There's a philosophy. And what we do in this, we sensitize the medical student for various problems, list of problems, right? And there are 28 types of thinking capacity. So at least few of that capacity we want to develop in the medical students. And the whole exercise is basically we make a list of problems and then out of the select few, and it is a group of five students, and they will be discussing among themselves and will select one question, and then they will work on for 3 months, 4 months, and then will go for the answer. All this technique is described in this whole PPT. Eight types of PPT I have shared in the group, and if you go through it, it will be a wonderful exercise. Right? So, for example, there is a list of problems. Out of this problem, when you select a problem, there are scientific way of selecting that you whether your capacity is there or not, whether there is any answer or not, etc. And on first day or second day, I talked about web of position, web of effect, etc. So you go through this PPT and try to conduct a workshop. The material is enough to do this. And once they have a list of problems, they need to select one problem, and that problem they have to refine in a way so that particular part of problem they can take and they try to solve it. And once they try to solve it, they will be making a plan, they refine the plan, and actually they do the things. I will give just one example. There is a 800 staff in our medical college, and out of that 200, the staff was the screened for anemia, and more than 50% were suffering from anemia. Now, if you want to solve this problem, we need to find out why this problem exists, and we may not be able to solve the problem of 200 people, but we can take a small sample of 15 or 20 employee and try to solve that problem. So it's not that a big problem they have to solve in a big number of people, but even a small sample, if they can solve even a small problem, for example, hair falling. Hair falling looks very big, but is not so big. You just change your lifestyle and your hair falling will go down. So this is a possibility. So problem solving for better in the workshop is to teach students to sensitize the students so that they can make a change in the society. And these are the question when you're going to solve the question. And there are so many solutions, but you may not be able to apply all the, for example, there's a malnutrition, you may not be able to provide food stuff to the people, but then you can train them how to what kind of a low cost recipe is available. If you can do that, they can solve the problem probably. So there's a group work to be done, right? And protocol is to be prepared on the second day. First day, you select the problem. Second day, how you are going to select the problem, right? So I just wanted to show you that this is given to you. You try to have a workshop, and for first few minutes, maybe 10 minutes, 15 minutes, I can address the gathering for that. Nothing which is important for me to talk to you how to we'll take one the Excel file. We'll talk something about sensitivity and specificity, and then how to change the scenario. Let's take any Excel file. Now, um, we choose a test. Let's say anemia detection. And I hope you have seen this poster. And same poster, I want to use it, increasing and decreasing sensitivity. So when basically there's a mirror in between, and surrounding are the um, photographs. One, two, three, four, 4 and 5. Then 6, 7, and 8. In between is a mirror. Now, this one is a red color, bright red color, right? And this is a pale color. These are the photographs over here, and that photographs will. This is a relatively less red. This is a less pale, and this is a, you can say, still lesser red, like this, right? This is in between. Middle colors are there. This is a still lesser pale. Now the question is, when you compare this in the society, people can see the in the mirror their tongue and find out whether they are anemic or not. And another idea is, when it is a self, it is a mirror. But when you want to examine someone else's tongue, there is a hole inside instead of the mirror. And then what will happen? Uh, we want to find out whether this test anemia poster is highly sensitive or highly specific or not. That why we want to compare with the hemoglobin level. So before I go for the sensitivity and specificity test, let me ask you a question. What do you mean by sensitivity and what do you mean by specificity? I will share one video of maybe 45 minutes or 30 minutes, which I have taken on net. The video study was done for that. Now, sensitivity is ability of a test to find out maximum out of total. If total are 100 and this test is able to find out 100 out of 100, then it is 100%. If this test is able to find out 80 cases, sensitivity is 80%. While specificity, if there are 40% are not suffering, and specificity says yes, 40% not suffering. So ability to detect that these are not having disease, then it is a 100%. So very choosy. If it is not there, it will say it is not there. That is the specificity. Now the question is, and there is something like positive predict value, negative predict value, false positive, false negative, etc. The thing words are that is complicated. Otherwise, positive predictive value means if a test is saying it is a positive, how much is true? That is a positive predictive value. If test says negative, how far it is true? How much really they are negative? That is the negative predictive value. But for false positive and false negative, false positive and false negative. So if you use the word false positive, false negative like this, false positive means falsely labeled as positive when actually it was negative. Falsely labeled as positive when actually it was negative. Then it is a false positive. False negative means falsely labeled as negative when it was positive. That is a false negative. Now, my question is over here that how we can change the sensitive specificity was by just changing the border. So I want to get your involvement in the chat. If I want to do the survey, let's say for hemoglobin level with this instrument, uh, in a larger scale in the society. So here in first screening, should I concentrate on sensitivity or specificity? When I go to the committee with this tool, I should emphasize more on sensitivity or specificity. Just give an answer in chat. You write something. If you don't know, write do not know. What do you understand, Danya? Sensitive because if there are 1,000 cases in society, you want to go for, if possible, 100% or 99%, so that you can find out all the 1,000 cases. And then before you start a treatment, you go for highly specific test, highly specific test, so that you don't give over the treatment. And rest of the thing you can keep on watch. Now, in this case, suppose if I use a borderline, those who are having three, I label them as enemy. And other criteria is those who are labeled as five, I will label them as enemy. So which one is more sensitive? If I take a three, is more sensitive in a labeling as anemia. If I take a five, is more sensitive. Tell me that. Looks very simple, but this judgment can save crores of rupees of our country. Tell me. If I take a 3 as a borderline for diagnosis as anemia, it will be more sensitive. Or if I take 5 as a borderline, it will be more sensitive. Which one will be more sensitive? Take few minutes, few seconds, and tell me the answer. Danya, can you give answer? So let us try to understand, because if we give three, if we give three, all the pale people, 8, 7, 6, 5, 4, will be found out that these are the anemic people. But if you take a 5 and those who are really anemic and they are in 3 and 4, they will be skipped. So in survey, in committee, we will be taking 3. But when we go on to give a treatment, at that time, not audible. Right now also I'm not audible. Am I audible now? Because the mic is perfectly working. Okay, okay. Okay, it's all right. We can talk sometimes on telephone. So, as far as specificity is concerned, if you take this 5 and 3, now, if you take this, even I would say this, if you take 6 and onwards as a anemia, you are less likely to overdiagnose. But if you take 3 onward all anemia, then 3 and 4 may not have anemia and you are overdiagnosing. So what you do the same, do only single test, right? And then all who are between 3 to 8 are screened labeled as anemia. Between 6, 7, 8 labeled as anemia pakka, give them treatment, give 3, 4 and 5 for observation. After 3 months, again do the test for them, and then only you decide whether to treat or not. With such a simple logic, crores of rupees can be solved, can be saved, because see, when we are doing overdiagnosis in field, you are bringing them to a stage, and then before giving a treatment, then you confirming the diagnosis, and then give a treatment. And borderline people are advised dietary advice that can be solved. And this is not applicable over here only. It's a question of something like when you talk about the measurement like blood pressure, BP, then comes sugar, everywhere. Sometimes If you go by normal distribution curve, then in society you will have 2.5% hypertensive, 2.5% hypertensive. If you go by normal curve, but normal distribution curve doesn't say it is a normal, it is a usual distribution curve. This you should remember. Otherwise, all the diseases, right? 2.5% hypo and 2.5% hyper is not like that. So just remember that each test, when you use it, try to use it a highly sensitive screening test first. And before you start the treatment, go for highly specific test. Rest of the people you keep as a borderline. That is the utility of the screening test. And when you want to compare the gold standard and the test, right? At that time, I have prepared a very good video, and that is very simple to understand. The positive predictive value, negative predictive value, false positive, false negative. It is very simple, and you will be understand much easily. Every time I try to repeat AP info because that will be the thing which you should be able to use it. Any question? So let me go to the AP info. Now, create forms and enter data is not a part of this course, but then you should be able to do it. Try to follow this and relatively very simple. Right? For example, creative form. You when you develop your protocol, you should be starting with a new project. And when you start with a new project, you give a name it. The database will be created. You can give a name of the form, and then you can drag and drop, or you can even add the things. And this is the you can enter the data, check data. This check code is also very important if you want to be a smaller programmer. If your age is less than 40 years around, then you can be a very good programmer also with this check code, right? But in data analysis we use classic. Visual dashboard is also in very advanced things you can do it. Here you should be able to recode command is also good. I think we should try to use this recode command today so that quickly you can the record the things. For another age group, if you want to decide, you can decide that. This is a record command we are using just for the sample. There are so many other commands which you should try to learn. Now, let us command define variable age group is X. Okay. Now, record age to age group value 1 to 20, recorded value 1 to 20. Yes, this 21 to 40, 21 to 40. 41 to 80, 41 to 80. Now I try to get a frequency of age group. Then automatically it found the 1 to 20 years, 26, 21 to 40 years, 41 to 80. This is the recoding the data, and then you can go for tables command. Age group versus illness. Okay. This is how you can do the analysis, right? So I wish that both of you try to use the AP info, and it will be very easy. You can use the means command, means of age versus illness. You can find out the mean and also standard error, right? Because p-value is 0.21, there is no significant difference between effect of the age on illness. Illness is more in older people, is not like that as far as this group is concerned, right? So try to use it as much as possible. There are other the aspect also, and try to use this because I say logistic regression, it is easier, right? You want to see the effect on the illness. What are the factors which can lead to illness? There are, let's say, five, six factors. So which food might lead to illness that you can select. And in logistic segregation, 0 and 0, yes, no kind of thing you can use it. And effect on the outcome. Okay? Like this, you can use. You should not take age over here. You can see which one is important or not. Right? You can say the yes and no or the ratio according to this yes no. If you see the male female, it is a less than one. It is favoring male are favored. They are less illness compared to the male. So this is how you can use this, and you can see the vanilla. The p value is less than 0.00. So vanilla is very much associated with illness. Let me stop it over here. But then I have a quick question that you can open up the mic. Both of you are using the AP Info software. Dr. Tukaram, are you using AP Info software?
Uh, yes, I will start from now on.
Yeah, so I think we have another 5, 6 session. I don't know how many session will be there till you are done. And then you have started using AP Info. Even
Sir,
yes,
my laptop is not supporting the FP info, I think.
any laptop supports. If you have Windows, it will support. You have Windows?
Yeah.
Or
Last time I have used, but I don't know. It's didn't work or something, sir.
I will share the number of my person, computer expert. You can connect with the desktop, any desk or TeamViewer. He will install for you if you wish, right?
Okay, sir. Thank.
Because if you learn everything, if you don't learn the AP info, how you can spread it further? So because it's just free, you may not you may know about SPSS which is costing maybe a 1,50,000 something like that. So why not use this simple for the medical students? So next time we'll be keeping on 18th, and keep your topic ready possible. 18th is a Tuesday, and you should prepare the protocol based on this PSP slides so already shared in the group. So we'll go through that project proposal and finish up the remaining thing. And I will share the my videos on the sensitivity specificity. You go through it. You might be aware, but it will be easier for you to explain the students for that matter. Right? Any question? Okay. Then I will be closing it.